All right, so today I will be explaining a problem out of the textbook pertaining to Gauss's sum. So as you can see, I wrote down the problem right here, but it says use the ideas in drawings A and B to find the solution to Gauss's problem for the sum 1 plus 2 plus 3, so on, plus n. And then explain your reasoning. So these figures are in the textbook, but I just decided it would be easier to copy them down for people to see. All right, so before I go into finding the solution to this problem and explaining the reasoning behind it, I'm just going to give a little background information about Gauss's sum because that will help us figure this out. So, story all originates with Carl Friedrich Gauss, and he was a German mathematician. And learning about this story in class is absolutely mind-boggling to me to think that a 10-year-old could figure this out. But basically, Gauss was messing around in math class one day, and his teacher asks him to find the sum of the whole numbers from 1 to 100, like something to keep him busy, keep him quiet. So Gauss goes back to his desk, and this is essentially what he finds out. So the sum of the whole numbers from 1 to 100, right? So the sum equals 1 plus 2 plus 3 all the way up to 100. 98, 99, 100. Then we can do the reverse of that, right? So we have 100, 99, 98. And then, this is what he finds out. So, 2 times the sum equals 101. And as you can see, the pattern continues where everything adds up to 101. All right, so we have 2 times the sum, so 2s, because the sum is 101, and we have 100 terms. We go 101 times 100. And that's basically what he came up with, but here's just another example of that. So let's say we are asked to find the sum of the whole numbers from 1 to 40. So we can actually use Gauss's sum to find this out. I mean, obviously you could count up, keep going up, but that's going to take a long time. So to save us that effort, we're going to write out numbers, so to 40. So just like Gauss, we take the last term and the first term, we add those together, we get 41. Interesting. And then we go 39, the second term, we also get 41. So same thing like Gauss, 41 every time. So on this question, because the sum is 41, and there are 20 pairs of numbers, we take 41 times 20. That gives us 100, gives us 820. All right, so now that we explained Gauss's sum, we can finally go back to our problem. So you might be sitting here thinking, well, how do I find the solution to Gauss's problem using these 2 figures? So I am going to explain that right now. So looking at figure A, it's kind of like building a staircase, if you want to put it that way. So first we have 1 block, 2, 3, 4, and so on, as you can see. So for that reason, I put the sum equals 1 plus 2 plus 3, so on until n, right? After that, looking at figure B, I realized there's twice as many blocks in figure B as there is in figure A. So, looking at that, I saw that there are n rows in B, and then there are n plus 1 columns, right? So for that reason, the number of blocks in figure B would be equaled to n times n plus 1. So that is what I got from that figure. All right, so because of that, over here I have my sum. I'm just going to write this out again. So equals 1 plus 2 plus 3, so on to n. So in order to find that solution, what I'm going to do is I'm going to set that equal to n times n plus 1, right? Because that's how many blocks are in figure B, right? And then because there are twice as many blocks in figure B compared to figure A, we are going to take that and divide it by 2. So that is how I reached the conclusion, and that is our final answer. So yeah, I hope that makes sense.